Okay, this second video is another video on composite surface area. We can see here that there's a silo at the right to be built from metal. The top portion of the silo is a cylinder of diameter 4 meters and height 8 meters. So diameter 4, height 8. The bottom part of the silo is a cone. The slant height is 3. The silo has a circular opening, which we can see here, and the circular opening has a radius of 30 centimetres. Now I can automatically see that everything else is in metres, so let's change that to 0.3 metres. 30 centimetres is 0.3 metres. What area of metal is required to build the silo? Okay, to build this silo, the area, we need to find the area of the top annulus, which is this shape here. We then need to find the area of the curved section of the cylinder, so this area here. If you like, that's kind of what, if we think about my can example, that's the label section of the can. And then we need to find the area of the curved section of the cone, and that's this area. If we add those three areas together, that gives us the area of metal required to build the silo. So for the annulus, I get the large circle minus the circle that's been cut out, and that gives me the area of the annulus, which is this area here. So I do my large circle, the radius is 2. If the diameter is 4, that must mean, so if that's 4 across there, half of 4 is 2. The radius is 2. So pi times 2 squared, and I subtract the smaller circle, which is pi times by 0.3 squared. That will give me the area of my annulus. So I'll put that into my calculator. And that gives me an area, if I'm rounding off to 2 decimal places, of 12.28 meters squared. The area of the curved section of the cylinder, the formula for that is 2 pi RH. So we say 2 times by pi times by 2, because the radius is 2, times by 8, which is the height. Putting that into my calculator, rounding off to 2 decimal points, is 100.53 meters squared. The area of the curved section of the cone. For the curved section of the cone, we use the formula pi RL. So we do pi times by 2, because that radius is 2. L stands for that slantish height, which is 3. Pi times 2 times 3. Entering that into the calculator, it gives us approximately 18.85 meters squared. So all up, the area, the total surface area, we add these together. So we go 12.28 plus 100.53 plus 18.85, and it gives us approximately 131.66 meters squared as our total surface area. So again, total surface area is the annulus on the top, the label or curved section of the cylinder, and just the curved section of the cone. The second part of the question says it costs $12.50 per metre square to cover it. So how much will it cost us if it's $12.50 per metre square? So what we do for the cost, but let's round that to the nearest metre, it's 132 metres, and we times that by $12.50 because that's the cost per metre. So that would cost us, if we were wanting to do that, $1,650.